So my name's ALAI, and in December of 2008, my friend Nolan Treadway asked me to make an art project for his art gallery. February of 2009, I presented this to him, and we put it up for this thing we have in Lincoln, Nebraska called First Friday, where a bunch of artists get together and they open their galleries to show what they've been working on. And it was a real pleasure to be able to put this in his gallery because over 200 people came by and wanted to use it, asked me questions about it, and it was really fun to watch people interact with it. And so I thought I'd make a quick video and put it up on the internet for everybody else to see. It's also a really good demonstration on how resistance works. Okay, so essentially what you do is you just wear this bracelet and drag out water from the sponges. Each sponge produces all 8 whole notes in an octave. This is C2 to C3 and this is C3 to C4. And as you listen, you can play all 8 whole notes. And the notes change based on the resistance that a little circuit that I built is feeding into the microcontroller that I programmed. And then that microcontroller sends information to some amplifying circuits that I built to the speakers. So you get an instant audio response with this visual layout of the water. This will do the notes higher than this one. And there are a multitude of patterns you can make with this, because you can draw out little shapes like a piano. And you can kind of make organic shapes like tree branches and stuff. And you can also network both sponges together. And you can make more of a harmonic melody between both sponges. And if you get really good, it's like some people at the exhibit were really good, and they could actually play recognizable tunes on this by just, on their first interaction, which I thought was pretty impressive because I can't really play very good songs on it, even though I've built it. So I'm kind of do. So you can play little tiny melodies on here too, but the main thing is that it gives you a visual representation of the amount of resistance you're putting in the circuit. Okay, so I was thinking of some future alterations to do to this, and what I plan on doing in the future is actually bringing up this whole board, making it perpendicular to the ground, and drilling a hole here and here, and having water pumping from an electric pump down out the hole, down the board into a trough where it'll be recycled back up to the top, and all the user has to do is actually just drag out water from the stream. That kind of reduces the need, excludes the needs for these sponges, because refilling the water was kind of a hassle. This is the brains behind the whole operation here. There are 2 microcontrollers. They're getting data from the circuits that I built, which pick up the small variations in resistance from the water being dragged out, and those go to the amplifying circuit. And it all runs off this lead-acid battery here. And the reason it's wrapped in aluminum foil is because the little circuits I built to pick up the small variations in resistance from the water are so sensitive that they will get interference from electromagnetic radiation. So if they're too close to a wall outlet, the alternating current going through the wires in your walls creates enough electromagnetic radiation to actually interfere with this, and it doesn't sound right. So this is kind of my cheapo way of protecting it from all that noise. But that's my art project / demonstration on how resistance works in electronic circuits. I don't think I got that much water. Then you can network the water together, and now it produces sounds on both speakers. It's supposed to be kind of right up here.